Good evening, everyone. I am your friend Tushar Mandal. Today, we will be discussing a small yet a very important topic from Module 4 of Software Engineering, that is Program Evolution Dynamics. Now, what is Program Evolution Dynamics? Program Evolution Dynamics is study of system change. Layman and Beledi proposed few laws for the system change. They claim these laws are likely to be true for all types of large organizational software systems. These systems in which the requirements are changing to reflect the changing business needs. New release of the systems are essential for the system to provide business value. As you know, software are important in every day-to-day life, and it is one of the main applications in business needs. Since business is of dynamic nature, the software has to be of dynamic nature to cope up with the business. Now let's move on to the laws of the Lehman's law of continuing change. A program that is used in a real-world environment must necessarily change or else become progressively less useful in that environment. As we see, the technology is advancing day by day. So hence, the program should be able to cope up with it, or else it is of no use. Law of increasing complexity. As an evolving program changes, its structure tends to become more complex. Extra resources must be devoted to preserving and simplifying the structure. You see, when a program evolves, we add more component to it, which makes its structure more complex. So, a business or an organization should spend its resources to keep the program as simple as possible. The third law, law of large program evolution. Program evolution is a self-regulating process. System attributes such as size, time between releases, and number of reported error is approximately invariant for each system release. Now the fourth law, organizational stability. Over a program's lifetime, its rate of development is approximately constant and independent of the resources devoted to the system. In a program's lifetime, the rate at which it develops is directly proportional to the resources which are being devoted for that system's development. That's the fourth law. Now, fifth law, conservation of familiarity. Over the lifetime of system, the incremental change in its release are approximately constant. You see, as the program develops, the incremental change in each releases or in each new releases is approximately should be kept constant. It should stay true to its true basic nature rather than becoming something else. Law of continuing growth. The functionality offered by the system has to continually increase to maintain user satisfaction. You see, as the time goes, the functionality offered by the program should vary its ranges. It should offer a varied ranges of functionality so that the user satisfaction is maintained. Next law, law of declining quality. The quality of system will decline unless they are modified to reflect change in operational environment. The quality of system will compulsorily decline if they aren't modified according to the operational environment. And the last law, law of feedback system. Evolution processes incorporate multi-tangent, multi-loop feedback systems, and you have to treat them as feedback system to achieve significant product improvement. You see, evolution processes have many steps in it, such as multi-tangent, multi-loop feedback system, and you have to treat all this as input to improve your product. Now, as you can see, the program evolution dynamics have been a repeated question. It has been asked in January February 2021 question paper, and it has been also asked in August September 2020 question paper with 8 marks and 10 marks respectively. Thank you. That's all for today.